Hello everyone, my name is Han Wang, and this is my learning portfolio for Comp 3530. This is week 2, and this week's topic is systems engineering. Okay, here we start. Well, I would like to make some brief summary about what we've learned this week. First of all, some general ideas about system engineering. I have to admit that I've heard about this word for a long time, but what I don't know is that it has been invited a long time ago. After a little bit search in the Wikipedia, I was taught that the system engineering, uh, the history of it could track back to 1940s, so even before the first computer was built. Uh, From this chart, we can see that there's a guy called systems engineer, and this guy just communicate between the customers and the development team to make sure the project works well, and also how important the system engineering is. I have to say that I was shocked when the first time I saw this chart, cause from this chart you can obviously see that the more you spend on system engineering, the more efficient your team would be. So that means if you got a chance to run a project later, you need to think about the budget carefully. You need to plan how much you would like to spend on system engineering, because that's really vital to your project. The third is some knowledge about systems and system science, like the system between environment and the systems. It consists of a bunch of elements and components that are in the interaction. Also, some system hierarchy things. And about system thinking, we've learned about hard system thinking and soft system thinking and the difference between them, and about dynamic systems will be taught next week, and I'm super excited about that. So the last part is the life cycle. For this part, talk we will talk about some models like the Scrum models, the waterfall models, and the algae models. Uh, those are what we've learned in Comp 2130 last semester. So that really helps us understanding the concepts of life cycle. So next, I would like to discuss how to make a successful project from my own perspective after I learned this course. So here I mean project. It also means a successful system, because abstractly you can treat your system as a project. First one is to read materials carefully. Here I mean materials, not only the requirements from your clients, from the customers, but also the relative informations about your project. It's like we all learned the quote from Walker Royce about the waterfall model. If people at that time notice that note, they might improve the waterfall model already, and then the techniques will be whole changes, and we can imagine how our lives would be nowadays. And the second one is to use separation of concerns. Consider your project as a whole system. We need to split it into different parts and to think about each part seriously, and you need to know how each part works, and then you can combine together. It's like if you're trying to make a computer, you need to know how CPU works, how the memory was stored, and how the input and output devices works, and how each part communicate with each other inside your computer. So after you think about this whole systems carefully, and you can start your project. And the third is to consider the relationships between the relative systems and always consider about it in a big picture. So according to the definition of systems, your system could also be an element or a component in another big system. So you need to figure out the role your system played in that bigger system. It's like you are making a computer. According to what I've learned in Comp 2410, your computer could also be a client or a host server in the internet system. That means your computer need to have an EUI 48 address and what we called MAC address in before. And also this because the system is interact with the environment, so it might have other relations between other system. So you need to figure that out and to plan about it. The fourth part is to use system thinking. About this one, I don't like to talk about it much today, because that's what we will learn formally next week. And next is always keep an eye on your project, even if it has already finished. And it's like if you're trying to build a system as a system engineer, you need to always focus on your system or as a project, because even if you finish it, you still need to maintain it, and you still need to change or updates according to the changes of requirements from your client. And not the last but also the most important one is to always contact with your client. And you need to know what really need, and you need to know the real requirements from your client. Because after all, a successful system must satisfy the needs of their customers, users, and other stakeholders. And at last, I would like to discuss the cockpit doors. We all know those two tragedies, and as far as I'm concerned, we can't solve this problem perfectly. It's like a paradox. If we do not have a cockpit doors, 9/11 might happen again because of the terrorists. But if we do make this cockpit door secure, the tragedy is like MH370 might happen. So it is really a complex question or problem. But I would like to treat those tragedies as the lessons we've learned. According to the law of requisite, the more information we got from the system, the more facts we learned, the more stable the system will be. So we need to learn something. We need to get some facts from those tragedies, and we might build a more stable appliance system in the future. So I got two possibly solutions for cockpit doors. The first one is to remote control the doors. It's like we give an authority to the cabin crews or just the leader of the crews, and when he wants to open the doors, and he need to send a notification to the airport. After the airport checked him, and the airport could open the doors by remote control. And the second one is to improve the security check at the airport. So, as we taught before, our systems are related. So if we prevent the terrorists from launch deploying, why would we need the cockpit doors? And that is so much for this week's learning portfolio. See you next week.